Good morning, students. Welcome back to science class on the chapter motion. Due to technical problem, yesterday the video was uploaded only 17 minutes, so no problem. Today, once again, I will take that in the same lesson. And one more thing. So, yesterday I had told only few students are responding and they are doing homework. Still, some students are not doing. Okay, so please do that. Whatever the homework given. Okay, just put it in your WhatsApp group. And some of your friends still they have not joined the WhatsApp group. So put their number on your WhatsApp group. We will add them. Okay. Yes, sir. See, in the previous class, we had discussed about speed, average speed, velocity. Okay, so today in this class we will study the rate of change of velocity. Okay, rate of change of velocity. Rate of change of velocity. See, observe here, rate of change of velocity. Okay, change of velocity. Now just imagine, while traveling, sometimes you have to change your speed. See, listen here, we are studying motion in a straight line. In a straight line, both speed and velocity are equal. Okay. See, while traveling, sometimes you have to reduce your velocity. Sometimes you will increase your velocity. Sometimes you will decrease your velocity. So depending on the road situation. Okay. So now suppose say one object is traveling A to B. Okay. See, at this position, velocity of one object say 4 meter per second. 4 meter per second. Okay, so now at this point here, its velocity is 4 meter per second only. At this point B also, its velocity is 4 meter per second. Okay, each and every point, velocity of that object is 4 meter per second. From A to B, that object traveled. Just imagine that object traveled A to B without changing the velocity, which means when traveling from A to B, that object traveled with the same speed or constant speed. Here that object didn't change its velocity. Okay. So now I will ask here, what is the change in velocity? That object traveled with the same speed. Change in velocity? Nothing, right? Because that object doesn't change its velocity. Okay, so now mathematically we can say that change in velocity is equal to 0, because here we have not see that object doesn't change its velocity, right? So that's why change in velocity of that object is 0, which means from A to B, that object traveled with the same velocity or constant velocity. In this case, the change in velocity is 0. Okay. Now take one more example. One object is traveling, okay, from A to B. At position A, at point A, say its velocity is 2 meter per second. 2 meter per second. Okay, so that object will travel A to B. Now at point B, its velocity is 4 meter per second. At the point A, its velocity is 2 meter per second, and at the point B, its velocity is 4 meter per second. So now see here that object changed its velocity, right, from 2 to 4. To change from 2 to 4, just imagine it will take 2 seconds. Okay, in 2 seconds that object changed its velocity from 2 meter per second to 4 meter per second. Okay. So now here we can say that here that object changed its velocity. Initially velocity of that object is 2 meter per second, and at this point velocity of that object is 4 meter per second. Here we can clearly say that that object changed its velocity. Okay, so now how to calculate that change in velocity? Yes, velocity changed, but what is the value that change in velocity? Okay, to understand that a change in velocity, here that object changed velocity, right? We introduce one more physical quantity, that is acceleration. That is acceleration. Okay, clear? Then what is acceleration? Acceleration means change in velocity in a given time. Here velocity changed, right? Velocity changed from 2 to 4 in 2 seconds. So we call this as acceleration. So acceleration means change in velocity in a given time, or we can say that in a given time, if the object, how many its velocity changed. Okay, so change in velocity in a given time is called acceleration. Okay, so acceleration equal to change in velocity divided by time taken. How many times it will take to change that velocity. Okay, so acceleration equal to change in velocity divided by time taken. Okay, so now how to write mathematically? So this is change in velocity, so we can write this as acceleration a is equals to v minus u divided by t. V a equal to v minus u divided by t. Okay, so here see, initially here this is point A and this is point B. Okay, see now at this point A, its velocity is 2 meter per second. What is that? Velocity is 2 meter per second. At this position, velocity is 4 meter per second. Okay, so now here velocity changed from 2 to 4. Okay, so now we can write that as v minus u. Here v means final velocity and u means initial velocity. Initial means starting. What is the starting velocity? So now this 2 meter per second is the starting velocity, right? So we call it as initial velocity. And what is the ending velocity or final? So it is 4 meter per second is the final velocity and this is the initial velocity. So we can write this change in velocity mathematically, say like this one. Okay, v minus u, which means final velocity minus initial velocity, and t means time taken. Okay, so now acceleration a equal to, what is the initial velocity? Initial velocity, sorry, what is final velocity? Final is 4 minus what is initial velocity? 2. That is divided by 2. So what is the answer? 4 minus 2, that is 2 divided by 2. 2 to get answer. Answer is 1 meter per second square. Okay, this meter per second square is the SI unit of acceleration. Okay, SI unit of acceleration is meter per second square. Okay, see here, meter per second square. While writing, some students will make the mistakes. You will write like this, meter per and minus. So this is completely wrong. You have to write like this, or you have to write like this, minus 2. Okay, so this is completely wrong. Okay, so you should write like this or like this, meter per second square or meter per second square. So this is the SI unit of acceleration. So a is equals to change in velocity divided by time taken. Okay, see, we can define acceleration. See, change in velocity in a given time, or we can define that acceleration as rate of change of velocity. What is that? Rate of change of velocity. Here the velocity is changing right in a given time. So that's why we use the rate of. Rate of what? Change in velocity. So that's why rate of change of velocity is called acceleration. We can define it that way also. Okay, so we can define acceleration as it is a change in velocity of an object in a given time, or the rate of change of velocity is called acceleration. If something is divided by time, then we use this word, that is rate of. Here velocity is changing in a given time, so that's why we say that a rate of what? Change in velocity. Okay, so rate of change of velocity is called acceleration. Okay, so now listen here. So one object is moving, say A to B. First it will move A to B, then A to C. Okay. See here at this point, say its velocity is 2 meter per second. 2 meter per second. Meter per second, and say at this point its velocity is 6 meter per second. Okay, so now when traveling from A to B, its velocity changes from 2 to 6 in say 2 seconds. In 2 seconds. Now its velocity changes from 6 to say 3 meter per second. 3 meter per second in 3 seconds. In 3 seconds. Okay, see, acceleration means what? Change in velocity. Here, see, you are traveling with some velocity, you will change it. Change means what? You can increase or you can decrease, whatever it is. No need to every time increase only. Okay, we won't call if the velocity increases, then we call it is that as acceleration. It's wrong. What acceleration means? Change in velocity. You can increase velocity or you can decrease. But here you have changed your velocity, right? Then we use that term, that is acceleration. Okay, you can increase your velocity or you can decrease your velocity. Whatever, but velocity changed, right? Then we use that word acceleration. Okay. See here now. Here velocity changed from 2 meter per second 2 to 6. Okay, and here 6 to 3. Okay. So here velocity changed in 2 seconds and here velocity changed in 3 seconds. First, I will calculate acceleration A to B. A to B. First one. Okay. So acceleration A equal to we know the formula, that is V minus U divided by time taken. Clear? So what is the final velocity? Final, see, first A to B. What is the final velocity? So this is the final velocity, that is 6 meter per second. And what is the initial velocity? This 2 is the initial velocity. Now substitute here. So V is 6 minus 2 divided by what is the time taken? Time taken 2 seconds. 2 seconds. So now calculate. So 6 minus 2 is equals to 4 and 2. Correct? 2 ones are 2 to that is 2 meter per second square. Yes, the acceleration between A and B is 2 meter per second square. Here velocity changed from 2 to 6, right, in 2 seconds. Then that change in velocity is 2 meter per second square. Okay, 2 meter per second square. Now, so now second case from B to C. B to C. B to C, here velocity changed from 6 meter per second to 3 meter per second. So we know the formula, acceleration equal to V minus U divided by time taken. What is V? V means final velocity. Here what is the final velocity? Here, see, earlier in the previous case, see, this was the what final velocity, but now in this case, so now it will become what initial velocity. Now this 6 meter per second is the initial velocity, and this 3 meter per second is the final velocity. Now substitute here. Final velocity is 3 minus initial is 6. What is the time taken? That is 3. Okay. 3 minus 6 plus 3 minus 6. What is the answer? Minus 3 divided by 3. Okay. So 3 will get the answer. So answer is minus 1 meter per second square. Okay. Here, see, don't forget to put the minus sign. Okay, some of you will make the mistakes. You won't put the if you won't put that minus symbol, which means then that answer is wrong. Okay. See here, observe here. Here you got -1 and here you got +2. Here 2 meter per second square and here -1 meter per second square. Here 1, here 2. But what about signs? Here you got positive and here you got negative. See this negative sign, what it represents, and here for +2, what it represents. Okay, see here in the first case, here the velocity changed from 2 to 6, which means here that object it increased its velocity, right? Here the velocity increased from 2 to 6. But what about here 6 to 3? Here the velocity decreased from 6 to 3. If the velocity increases, then we will get the acceleration in positive. If the velocity reduces, then we will get the acceleration in negative. Okay, so we call this is negative acceleration or deceleration, and this is positive acceleration. Okay, so here this is +2, which represents velocity increased. Velocity increased, and here minus represents velocity decreased. If the velocity decreases, then we will get the acceleration in negative. If the velocity increases, then we will get the velocity positive. Okay, so clear the difference between the positive and negative values. Okay. Okay, so now we'll discuss one small problem related to acceleration. See here. Yes. So now see here, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Okay. See here, Rahul pedals his bicycle to attain a velocity of 6 meter per second. To gain velocity, he will pedal that bicycle. Okay, and he gains that velocity is that is 6 meter per second. Next, then he applies brakes. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. In the next 5 seconds, calculate the acceleration of the bicycle in both the cases. Here we need acceleration, or we should calculate the acceleration in both the cases. Yes, we know the formula. What is the formula? That is so A is V minus U divided by time taken. Okay, time taken. See, in the first case, see, what is this in the first case? Here they have given only one value, right? Starting from stationary position. See, here they have mentioned starting point, starting from a stationary position, which means that object, okay, moved that bicycle. Initially, it was at rest, but now it is, then later it gains 6 meter per second. So initially that object is at rest. So that's why we should write initial velocity u is equals to 0. U is equals to 0. Why? Because starting from a stationary position. Stationary means what? That object is at rest. Okay. So that's why here initial velocity is equal to 0. Next, Rahul pedals his bicycle to attain a velocity. It gains some velocity, right? So now here this 6 meter per second is the final velocity. So V is equals to 6 meter per second. Okay. So what is the time here? Velocity changed. Initially the velocity changed from 0 to 6 meter per second. Okay. Velocity changes from 0 to 6 meter per second. At what time? In 30 seconds. In 30 seconds. Yes. So now substitute the values. Find the answer. Okay. See here, the final velocity is 6 meter and initial velocity is 0. Okay. Then time is 30 seconds. Time is 30 seconds. Okay. 6 minus 0, that is 0. 6 divided by 30. And right here, so acceleration equal to 0.2 meter per second square. 6 ones are 6 twos are, sorry, 6 fives are. So 1 by 5. Okay. So 1 by 5 is equals to 0.2, right? So acceleration in the first case is 0.2 meter per second square. Okay. Here we got positive, right? Plus 0.2. Why? Here velocity increased because from 0 to 6, 6 is greater than 0. So here velocity increases. So that's why we got answer in positive. Okay. Next. Now second case. In the first case, we got A equal to 0.2 meter per second square. Clear? Now in the second case, see. Then he applies brakes after reaching the 6 meter per second. Okay, then he applies the brakes such that the velocity of the bicycle comes down to 4 meter. Here its velocity, see, reduces to 4. Why? Because he applies the brake, he applied brakes, right? So that's why its velocity reduced from 6 meter per second to 4 meter per second. So now here initial velocity. So now this 6 meter per second is the initial velocity. In this case, velocity changed from 6 to 4. Okay, 6 meter per second to 4 meter per second, right? Okay. So now this 6 is the initial velocity and 4 is the final velocity. So initial velocity is 6 meter per second and the final velocity is 4 meter per second. So whatever we see here, velocity changes from 6 to 4. What about time? Here this velocity change. Okay, so t is equals to 5 seconds. Next, so acceleration a is equals to, what is final velocity? Final velocity is 4. What is initial velocity? That is 6. Divided by time taken 5. Okay, 4 minus 6 is 2 by 5. So what is the answer of 2 by 5? 2 by 5 is, sorry, here minus 2, right? Why? Because plus 4 and minus 6, that is equal to minus 2. If you divide this one, so we will get minus 0.4 meter per. So I will write here. So we will get minus 0.4 meter per second square. Okay. See here in the second case we got acceleration in negative. Why? Because here the velocity reduced from 6 to 4. Because 6 is greater than 4, right? Here velocity decreased. So that's why we got acceleration in negative. In the first case velocity has increased. So that's why we got acceleration in positive. In the second case velocity decreased. That's why we got acceleration in the second case, that is in the negative. Okay, so now this is the first case and this is the second case. In the first case a equal to plus 0. In the second case minus 0.4 meter per second square. Okay, see here that negative sign indicates what? Acceleration decreases. Okay, see here, you know, normally in your hand you can show, for example in my hand I can show 1 marker, 2 marker, 3 marker. Okay, I can show, but how to show minus 1 marker, minus 2 and minus 3 markers? It is impossible, right? Why? Because in maths we call those numbers are imaginary numbers, not real numbers. Because you can't show minus 1 marker, minus 2 marker. You can show minus plus 1. See, now this is 1 marker, 2 markers, 3 markers. But what about minus 1, minus 2, minus 3? So we can't show, right? So that's why we call such numbers are imaginary numbers. Here, this negative sign which indicates what, whether the acceleration is increased or decreased. Okay, so here we got minus, right? The meaning of this minus is the velocity is decreased. Okay. Yes, and one more thing here. See, initially velocity changed from 0 to 6. Here they have mentioned 6 meter per second the question, but here they have not mentioned 0. Okay. See, sometimes in problems they won't mention this 0. Initial velocity is 0 like that, but they will mention in another way. See here, they have mentioned here starting from a stationary position. This stationary position represents. So here, if they mention like this, then see, you should think what? This is initial velocity and this initial velocity is equal to 0. Here you should think what? That object is at rest. Okay. See, listen here, when the object, okay, if it comes, you see, initially at rest, then it will gain some velocity. So, but when it is at rest, at that time, when it starts from rest, and the object starts from rest, at that time, always you should take initial velocity is equals to 0. Okay. So, for example, starting from a rest, one object, it gains say velocity is 2 meter per second. Starting from rest, here you should take initial velocity is equal to 0 and final velocity is equal to 2 meter per second. So when an object starts from a rest, at that time always you should take initial velocity is equal to 0. Okay. Sometimes in problems, so one object it is traveling with some velocity. Finally it comes to rest. Okay, what is that? One object is traveling with some velocity, say 6 meter per second. One object is traveling with 6 meter per second velocity. Then it will comes to rest. Then it will come to rest. At that time, you should take final velocity is equals to 0. Why? Because they have see they will mention what it comes to rest. It comes to rest. Rest means what? 0, right? 0. Finally, it comes to rest. At that time, you should take final velocity is equals to 0. And see that object is moving with the initial moving with 6 meter per second velocity. Then it will come to rest. At that time, you should take initial velocity is equals to 6 and final velocity is equal to 0. You should know when we should take initial velocity is equals to 0 and final velocity is equal to 0. If an object starting from rest, then you should take initial velocity equal to 0. If an object, okay, it will come to rest, at that time you should take final velocity is equal to 0. Okay. Look, this is your connection is unstable. I will stop here. Tomorrow I will continue the class. Net